Bismillahirrahmanirrahim. Assalamu alaikum, dear students. From Pakistan School Salala, Mrs. Iram Shahid says you welcome for your grade 7 general science lesson of week 10. And we will see unit number 7, sound and hearing, about exercise of this unit. Dear students, you have already watched unit number 7 5 videos, and in all those videos you have seen that almost 6 videos you have watched. So in all those videos you have learned all the concepts about unit number 7. Now it's time to have some conceptual based discussion that I have selected exercise questions for you to make your concept clear, and it will be more interesting for you. So in this video lesson, students, we are going to discuss our exercise page 93, question number 1. Let's see what's that. Yes, dear students, it's time to have an activity because it's mentioned in your book, and you will enjoy this multiple choice questions, because in this question, this type of questions, there will be 4 options given to you and you have to as an answer. So you don't have to write or learn so many long answers or short answers, and just you have to tick or encircle any one of the best option. So let's see our first question. Our first question is, how does sound travel from one place to another? So let's see what are the options given to us. A, lateral waves, and B is latitudinal waves. C is lengthways waves, and D is longitudinal waves. You will take little pause, you will think about the answer, and then you will be definitely coming back with your right option. So you have to select one option. So our option is exactly, it's D part. Sound waves travel from one place to another as longitudinal waves. Let's see our question number 2. Sound cannot pass through a... Yes, you have to guess the answer. So let's see what are the options given to us. We will be given 4 options and we have to select the best one. A, gas. B, liquid. C, solid. D, vacuum. Now again you will take a pause and you will think about the answer, and if you have watched previous video lessons keenly and you have read from the book all the concept, the answer at once come to your mind. That is, yes, exactly, it's D. Sound cannot pass through a vacuum. So let's start with our next question and see what question is given to us. Yes, a sound can be modeled by using a slinky spring. A wavelength in this model is... This is our question. Let's move what options are given to us. We are provided with 4 options and we have to select the best one. Is it an interesting game? Yes, it is interesting. So the distance between a rarefaction and a compression, the length of one compression, the length of one rarefaction, the distance between 2 rarefactions. It would be interesting to answer such kind of question if we knew answer, new concepts, new background of the chapter. If we have learned all the concepts, you have watched all the video lessons, then this MCQs based questions, they are very interesting to answer because they don't require long answers to be learning, long answers to be writing, short answers, and the same way. So dear students, they will give you marks as well, and mathematically they can give you marks. So if you have idea of rarefaction and compression, then you can define wavelengths. So for this we can recall a figure. You can see that yes, it's a compressional wave, a longitudinal wave that we have studied in the spring. So here the compression means the part of the wave which have particles closer together, and rarefaction where the particles, they are spread out, they are not closer together. Now what is wavelength? Yes, by looking up the figure you can easily decide what is wavelength. Wavelength is distance between two rarefaction or distance between two compressions. Neither one length of compression, one rarefaction, or distance between rarefaction and compression, these first three options, they are wrong. So what is the correct one? The distance between two rarefaction is called a wavelength. In this way, if you have learned all the concept, it will be easy for you to attempt such kind of questions. Yes, D option is our correct option. So next we have to move our another question. Next question, let's see what question is given to us. Sound is measured in, let's see its options. Sound is measured in hertz. Think of that. Sound is measured in meters. Yes, please think. Sound is measured in ohms. Have we heard anything about ohms in any video lesson of sound and hearing? Think about that. Sound is measured in pascals. So which terms you were using a lot? If you have watched video lessons, you can easily describe. Yes, it can be hertz or it can be meters. I can give you two options. So meters, hertz, meter, which would be the best option? Exactly, dear student, when you think about that, you can clearly get the answer, and it is option A, hertz. So in this way you are recalling your lesson, your concepts, basic definitions. Yes, I knew that you are waiting for the next question. Let's see our next question. Exactly, now our next question is in front of us. Sound with high frequency have a, we have to see what is the relationship between frequency and sound, and then we have to think about our answer. So let's see our options what are given to us. Let's see that from the given option we can guess the answer or not. We are provided with first option, that is high pitch, high volume, low pitch, low volume. So which option is related to that? If you think about a concept, then you will be able to answer at once. So whenever MCQs are given to you, they are always concept based, they are having some calculations as well, they have also some learning aspects as well. So all these concepts should be strong from your side. So you have to work on for your books, you have to work on with your concepts, and you have to work on for your learning, so then you would be able to answer them quickly. So let's see what's the concept behind. Exactly, this concept we have done our previous week video lesson, and we have think that what is low pitch and what is high pitch and how they are related with the sound. If we have low pitch, means less number of waves, Less number of waves means less number of vibrations. Less number of vibrations means less frequency. So low pitch, less vibrations, less frequency. Low pitch. High pitch, more number of waves, more number of frequency. So if the waves are greater, you can count here waves. If waves they are greater in number, more in number, they will vibrate more and more. And if they vibrate more and more, they will be having high frequency, and hence their pitch will be high. So you have to remember this concept. So you can see, suppose it is 1 second, suppose 1 second only 2 vibrations, and 1 seconds only how many vibrations? 1, 2, 3, 4, 5 and 6. 6 vibrations. So 6 vibrations means high frequency, high pitch. So let's see what's our answer. Yes, so high pitch, high vibration, high frequency means our sound is high. Okay, so sound is having high pitch. So on the other hand, if the frequency is low, of the sound frequency is low, it means less vibrations and low pitch. Dear students, hopefully you enjoyed your lesson. Today's video lesson was interesting because there are no long questions, no short questions, only you have to encircle the best option. So hopefully you enjoyed your lesson, and please keep on watching video lessons to have your concepts clear, better concepts. You have to watch your videos, you have to work your assignments nicely, and exactly, these are nowadays you are fasting as well, so say your prayers 5 times a day on time, and remember me in your prayers. Thank you so much. Allah Hafiz.